Welcome to our screencast for writing proportions. In this screencast, you're going to learn how to write a proportion in an applied setting. Or basically, we're just going to be focusing on setting up a proportion for a word problem that you might come across. So, before having a good understanding of how we're going to be writing proportions, you need to be comfortable with ratios and how they work. Ratios are just another fancy way of saying fractions. And we need this lesson because in future lessons, we're going to be expected to write and solve proportions. So what our instructions are to write 3 equivalent proportions that could be used to solve the following problem. And basically what I'm just asking you guys to do is set up the problem in 3 different ways. Now, the interesting thing is that there are 8 correct possible answers. And we're only asking you to write 3 of them. So that's kind of nice. But we need to talk about that, what we're going to be doing to set up one of these 3 correct answers. And I'm going to try and take you through my thinking. So the question is, if 7 limes cost $8.96, what is the cost of 5 limes? Now, so basically what we're looking at here is we have the number of limes compared to a cost. So that might be one way that we can set this up. We also have like our original situation of 7 limes costing $8.96. And we have this new situation where we have to take a look at 5 limes and what that cost could be. So if we have to set up 7 problems, if we have to set up 3 different proportions, I am just going to, give myself some workspace. And for me, I think it's all about the labels. I think once we get the labels in place, putting the numbers in place is really not too bad. So one way that you could think about our first ratio is taking a look at just the original information. Like the first thing that we were told about was 7 limes. So that's going to be my numerator of my first ratio. And the other thing that we were told was comparing the cost. So that's like our first pieces of information. So we would have the original number of limes to the original cost. So that would be our first ratio. Now, if this is the way that I'm setting up my first ratio and I need to set up a proportion, I kind of have to keep things in the same spot. So in my second ratio, I'm going to have to be comparing number of limes to cost because that's how we have it set up. But instead of looking at the original information, I'm going to be looking at the new information. So one correct proportion, looking at the labels, would be original number of limes to the original cost has to be the same as the new number of limes to the new cost. So remember, limes are going to be in our numerators and cost is going to be in our denominators. Now that I have my labels all set up, I can just go ahead and substitute the numbers. The original number of limes was 7. The original cost was $8.96. That's going to be equal to the new number of limes, which was 5, and the new cost, which we don't know, so I'm going to go ahead and use a variable. So that's one possible proportion that we could use. Like I said, there's 8 correct versions, so let's see if we can come up with a different version. Now, the way that I tend to think is not how the problem is presented. The way that I think is, what's the information that I'm going to be solving for? So for me, I want to know what's the cost. That's what I'm going to start with. And I want to know the cost of 5 limes. So I'm looking for information in our new setting. So because I want to know what is the cost, that's going to be for me in the numerator, because that's the first thing that I see. What's the question that I'm asking? I want that to be top front, new cost. And in my new situation, I want to know what's the new cost related to the new number of limes. So here in my first ratio, I have my new scenario. and I need to compare that to the original scenario. Now, in this case, my cost is in the numerator and my number of limes is in the denominator. So in my new ratio, I need to keep the ratio cost to limes. So in looking at the labels, it's original cost to original limes. So my new cost to new limes is going to be the same as my original cost to the original limes. And then again, I don't know my new cost, so that's going to be my variable. So x to 5 is equal to 896 to 7. So that's just another version, another way of thinking. Now, in keeping with just another way of looking at it, I might want to keep my new cost in the numerator because that's just the way that I think. And I might want to compare costs in my first ratio. So what's the new cost to my original cost? So I've already taken care of the costs here. In my other ratio, I'm going to have to be looking at number of limes. And again, I'm going to keep that new in the numerator and original in the denominator. So my next would be new number of limes to original number of limes. So we have to keep in mind, I'm trying to use color to help highlight, but you're either comparing originals to news, you're comparing costs to limes, and just make sure that your labels are being consistent amongst both ratios. So I will fill in my next one, and that would be my new cost, which I don't know is X, to my original cost, which was 896. My new number of limes that I want is 5, and my original number of limes is 7. So that's just taking you through my thinking. You can either, some people like to write proportions just as they see it. I'm going to write it as the words that I see. So if the words come first, that's what I'm going to put in my first one. For me, the way that I think, I always want to know what's the question, and then that is my first numerator. Okay, let's take a look at another example. We're looking at, again, writing 3 equivalent proportions, and then we just stop. So we don't actually have to solve any of it. And we have Sam raked 3 bags of leaves in 16 minutes. How long will it take Sam to rake 7 bags of leaves? So we just could be looking again, if you're going to take a look at, the information that was given, we have bags of leaves and 16 minutes. So the original scenario, original bags to original minutes. So I've already dealt with my original information. I need to find out new information in my second ratio, and I need to keep it bags to minutes. So my second ratio would be new bags to new minutes. And once I get my label set up, it's, just a matter of putting in the information. So the original bags was 3, the original minutes was 16, the new bags was 7, and we don't know how long it's going to take, so that's my variable. So I think some students are comfortable, just taking the first piece of information and writing a ratio. Again, that's not how I think. I think, what's the question? The question is asking about the new minutes. So for me, that's going to go in the numerator. And then you could compare new minutes to the new bags of leaves, in which case now my next ratio is going to be the original information, and I need to be minutes to bags. So original minutes to original bags, and we'll just, substitute that information there. Or you could take a look at new minutes maybe to original minutes. So I don't know how long it took before. Sorry, I don't know how long it will take, but I do know that it took 16 minutes before. And then we just need to make sure that we're doing new to original bags. New bags to original bags. And then just go ahead and substitute your information. So in general, when you're trying to set up these problems, it's really spend your time focusing on the labels And then you can worry about the actual numbers or variables as you go through. So those were two examples on how to write proportions in an applied setting. And that is our screencast.